Hey guys, so I hope everyone are doing great. So in this video we will discuss about some of the database concept. Okay, so we are going to deep dive into some of the architecture of the database. Okay, so mainly we will discuss the architecture of the Postgres, how it is there. Because architecture before getting deep into that one, so knowing the architecture at the high level and the low level, it is important because it helps when you want to optimize your queries and you want to optimize your database read and write performance. Okay, so understanding about the architecture is very important. What are the components are there, how all these things works, because database is all about read and writes mainly. Okay, so we are going to discuss about the architecture of the Postgres. Okay, so let's start it then. And if you are new to our channel, so don't forget to subscribe it, because of your one subscribe we can reach out to the more people. Okay, so because of your one subscribe and more people can get a knowledge. Okay, so let's get this started then. So the Postgres architecture is okay. So first I will split this into two different parts. One is for the high level architecture, one is for the low level. In a high level I will explain you about the how all the things are connected with each other. In the lower level I will get a deep dive into that one, and I will explain each and everything. Okay, so whenever you request or write or insert something into the database, okay, so lot of different things will go on back behind the scenes. Okay, so as a user, front end user, we cannot see that one, but inside the database, in the backend of the database, lot of the different things will go on. So suppose this is the user is there. This is a user, okay, who is writing or uh, reading something from that. Okay, as of now we will take a write. Okay, so whenever the database is there, so in a Postgres, okay, so I will mainly concentrate on the Postgres in this video. So in the Postgres there is a two memory locations are there. One is for the disk, another one is for the in memory RAM. So why two memory locations are there to store the data? So as we all know, so storing into the disk and reading from the disk is a slow one compared to the RAM, because in your mobile also, when you minimize something and open it again, so it will open faster because it's stored in a RAM. If you minimize and clear all the task managers, and again if you want to try to open that app, so it will take a time, because again it has to read from the disk. So like the same thing in the Postgres also, in the databases also, so the data directly will not go to the disk in a Postgres. Okay, so as I told, okay, so first it will come to the RAM. We in Postgres this is called as a shared buffer. Okay, and the disk will be like this. Okay, disk is like this one. So whenever the request you make, okay, so assume you are inserting something. Insert John, his email ID and his phone number you want to insert. So first it will insert into the RAM. Okay, because we got to know that okay, RAM is faster in terms of the read and write. Okay, so after periodically, that whatever the data stored in the RAM, it will be sent to the disk. Okay, so this is high level overview. Okay, first understand this one. So after that I will get into the low level. Okay, so after that it will go into the disk. So first it will go into the RAM. After that, periodically the Postgres what it does is it take all the data which are there in the RAM and it will insert into the disk. Okay, now the question is the RAM is there. Okay, so RAM, as we already know, so the if the machine goes down or anything like that, so whatever the data inside the RAM, it will go. If we switch off the mobile also, all the data in the RAM it will go. Okay, so all the app we open all will be cleared. So like the same thing in the database also. Now the problem is, now the question is, what if I stored something in the RAM? Okay, something was stored in the RAM. Before flushing into the disk periodically, between that and only this RAM goes down, this whole database goes down, then all the data which I inserted in the RAM, it will be lost, right? So that is the question arises. But Postgres handle this with very clearly. Every database have this one. Okay, so how they handle is, so they have a WAL, write ahead logs. This is very important. Write ahead logs. So what are the write ahead logs is nothing but, so whatever the transaction you are doing, either insert, update, delete, each and every transaction against the database, so everything will be recorded into the write ahead log. So it is kind of a log file will be there. Okay, so if I take like this is a write ahead log. So suppose you inserted something, insert John, his email ID and everything. So it is inserted in the RAM, and after that, that log will be written here in the WL file. What it will be there is, it's just a query will be there. Insert into this, some query will be there. However, WL file is a not human readable. Okay, but I will show you at a high level how it looks like. Okay, so in WL file, all the transaction will be there. So insert, delete, whatever you are doing, whatever the user is doing. So now see how they handle the failure is. So now whatever the transaction is, we are recording into the WAL. So now if the shared buffer goes down also, if it runs again, even though there is no data is there, but all the things are stored here, right? WAL. So this will not be lost. Okay, so this is a log file. So if the crash, whatever happen, so all the record, it will be there inside that one. Okay, so if the database, this shared buffer goes down also, so Postgres, what it does is it again replay the all the transaction in the WAL. Okay, so assume 10 records you inserted. Okay, so it's stored in the shared buffer, and in the middle, before inserting into the disk, shared buffer goes down. So now there is no data in the shared buffer. So what Postgres does is it will go to that WAL file. So it will check all the queries, insert into some 20 queries will be there, right? For 10 records. So it will replay it. So again, all the data will be inserted again in the shared buffer. So this is how they will overcome from the failure. Okay. And when the, now the question is also like, when the this periodically data will be flushed into the disk. It is flushed when WAL file is full. Okay, it reaches to some point. Either you can set it or Postgres will do it automatically, whatever you can do it. Okay, so assume we are once the WAL file reaches its maximum, then it will trigger a checkpoint. The Postgres will trigger a checkpoint once it reaches to the maximum size. So once the checkpoint is triggered, so it will be flushed into the disk, all the data. Okay, so all the data will be flushed into the disk. Hmm. So now while flushing also, as I told, failure happens. So assume you have some 10 rows is there. Okay, so see how the checkpoint also work. It is very important. So now assume 10 records is there while inserting into the disk. So upon, in the 10 records, 5 records has been inserted. But when inserting the sixth record, the crash or something happened. Those the rest of the 5 records is not inserted. So now checkpoint make sure that after every insert, okay, so there will be like how many records has been inserted. So checkpoint will maintain that point. So assume from the 10 records, 5 records has been inserted. So checkpoint is at pointing at the fifth record right now. So if the below record fail also, and if the disk fail or whatever happen, so Postgres will rerun that one, replay that one from the sixth record only, because already 5 records has been inserted. So that is what checkpoint do. So it will make sure that until what data has been inserted. Okay, and it will, if the if it run against, it will run from the last checkpoint. Remember this, it will run from the last checkpoint where it left off, here in the case from the sixth record. Okay, so now all the data has been inserted and you committed the changes also. So commit in the sense you saying that okay, I done with all the changes. Okay, so once you committed again, the WL file, it will remove all the logs and everything, again start freshly, or you can keep it also. WL file, it is very important. Okay, all the logs which is run against your database. Okay, so this is how high level overview all the things works. So now we'll get into the low level. Okay, so high level, it is a very simple. Okay, so user comes, he first his request will not go to directly disk. First it will go to the shared buffer, and after that to make it in the failure to handle it correctly, so all the transaction will be returned to the WAL. So over there all the queries will be there, and once the WAL is full, at periodically once it is full, so all the things will be flushed into the disk. So now see, this is insert part. So now what about the read? So we know that read is also from like a fast, compared to the disk, RAM is fast while reading. So here, so while you are reading, so your first the request will not directly go to the disk again. So first it will check the buffer. First it will check the buffer. So buffer is, there is a cached data will be there. So periodically a lot of people are querying the data from the disk. Okay, some 10 users are there, everyone are querying some data, and there might be a possible that 2-3 person query the same data. So in the databases cache, how it works is, so if someone query the data, so it will keep that cache inside the shared buffer. Okay, and if the user requested the same thing, it will directly satisfy with the shared buffer only, it will not pass the request to the disk. Okay, and only it will go to the request go to the disk when the data is not there in the shared buffer. Okay, so then only it will go, and if you go to the disk also, then again it will take that data and keep it into the shared buffer. Maybe it can help in the next query, someone querying the data. Okay, so for them it may be helpful, that cache. Okay, so let us see now the low level, how it works, all the things. Okay, how the architecture works in the low level. Okay, so one thing we have to notice. Okay, so this is the user is there. Okay, so we have a shared buffer is there. Okay, and we have the disk over here. And remember, in no database, all the data is stored into the single block. You have to remember this one, it is a very important. Okay, no database store all the data into the single block. All the data are stored in every database, in a Postgres also, in a chunks, in a small blocks, that we call it as a pages. Okay, so pages, it will store the data. It is a small block of the map small block of which holds the data. Assume you have a 10 rows, a small block hold that 10 rows. So why this we are storing into the blocks? Why can't we store entire thing in a one block? So if I give an example, assume you stored everything inside the one block only, one huge block. You have 1 terabyte of data. Okay, so here you have in the disk, you have 1 terabyte of data. So you stored everything inside the same block. Now you only need some 2-3 rows you need. Okay, only need a 2-3 rows, 2 to 3 rows. So now Postgres have to, because memories are work with the blocks. Okay, so Postgres have to pull all this 1 TB of data into the memory, and it will give, it have to give to you whole 1 TB, even though you need only 1 or 2 row, right? So it has to pull every data, full entire block it has to pull. So this is not efficient because you are unnecessarily taking the reading the data, okay, whole memory block. So what the Postgres does is, so everything will be stored into the smartphone block. So pages will be 8 KB. Okay, so 8 KB of pages will be there. In different database, it's a different size will be there. Okay, so in MySQL it is a 16 KB. Okay, in different databases, different page size will be there. So it will be stored like this. So in disk also it will be stored like this. Okay, so now why what happens when we store into the blocks is inside the pages is, so in future you requested only few amount of data, so Postgres will read only one block. Okay, only one block and give it to you instead of querying each and every block. Okay, because right now we s- cut down one, okay, and spread it into the chunks, kept into the chunks. Okay, and what happened, okay, so is this is the 8 KB. What happened, my data is a full of some 10 KB or 20 KB data is there, so then it will spill over to the next block. So right now you inserted some data, some 20 rows, 30 rows. If it not fits inside the one block, then obviously the rest of the data will be spilled into the next block. So this is done by the toast. So toast is a methodology which makes that whatever the data is overflowing in the one block, it will keep it into the next block and make that reference. This reference is very important because it has to refer, right? So where is the next data? So this is the, assume this is the first one and this is the second one. And from the first data, first block, it has been overflowed and kept here. So this has to make the reference, means when someone is querying the data, okay, when someone is querying the data here, so when they query this block, it has to make sure that take this also with it. Okay, because both are same thing only, right? Because just we stored over there overflowed data, but we have all the data or related data in this also. So that's why reference is important. So toast will make sure that all is done properly. So this is how this 8 KB 8 KB 8 KB 8 KB kind of a data will be stored in all the memory locations. So now let's see, okay, so if I give an example, this shared buffer we have and this data we have. Assume these are the blocks. Okay, so this is one block, this is again another block, this is again another block. Okay, some 8 KB of a kind of a blocks are there. So obviously, as I told in the above, okay, so it will be stored into the 8 KB, and after that, so now I will show you how the WL file look like. So see here how the WL file look like is, so transaction will be there, start transaction, and see here insert operation, user ID, name and everything, John, his email ID, okay, and update transaction, someone did the update transaction, so John, this one. Okay, so now WL file maintain all these things, it can keep here. So when the uh, database or anything goes down also, for Postgres from that WL file, it will run those all these transactions again. It will run all these transactions again. Okay, so from that it will get to know that, okay, whatever the transaction has been done, okay, so I have to make sure that all run again, it will insert again, it will update again, it will delete. Okay, so this is how it works. And the checkpoint which I am talking. Okay, so now assume this all the it has been full right now, the WL file has been full right now. So it will periodically, as I told, checkpoint will trigger once it is full, and after that while you are inserting it to the disk, so at this point everything has been inserted. So at this point, before inserting this delete operation, the something goes down, something crashes, so this delete operation is not done. Okay, so these are done. Okay, so these both things are done. Okay, so this delete operation is not done. So now checkpoint is pointing at here. Okay, so checkpoint is pointing at this position. So now again, if the database comes up and running, okay, so disk up and running, so the Postgres will run the queries from the last checkpoint where it has been left off, because it has already inserted, right? So it will run this one, delete operation. So once it is successfully inserted, so it will commit the transaction after everything. Okay, you can commit the transaction, means I am done with everything. So all the transaction has flushed into the disk. So now after that, usually, okay, so you can keep this WL file entire, whatever the transaction, or you can clear it also, whatever things you can do. Okay, so this is how the whole things works at a low level. Okay, so this is very important. Okay, as we saw, what are the things we discussed. Okay, so user, page size are just nothing but it's a small blocks. Okay, and the shared buffer, why it has been shared buffer is nothing but a in memory RAM kind of a thing. Okay, so and disk is at the final, the data where it's stored. So once the RAM is full, you can keep the configuration that once it is full, you can flush it, or you can set a parameter also based on the, if the page sizes are reached this much, 100 page size, or not 100 pages has been inserted, then you can insert that one. So the Postgres give you a lot of different configuration which you can use. Okay, so you can set the parameters. So this is how all these things works. So in your next video, we'll look into how each and everything works with the hands-on. Okay, how the WL file where it will be written, and how to change the configuration of the shared buffer, each and everything we can see. Okay, so thank you so much for watching, and don't forget to subscribe the channel if you found this video is knowledgeable, and share with your colleagues and fellow mates also. And thank you so much for watching, and stay tuned with our next video. Okay, so turn on the notification, and thank you.